Hello and welcome to this course. In this course, we will learn how to make a CAD model and turn it into the 3D object. First, we will have the idea. If you have some idea that you want to turn into an object, you can create it into a CAD model and then you can turn it into STL file and slice it using a slicing software. The sliced part will be printed in the 3D printer and create the 3D objects. We can create a 3D design using a CAD application. For instance, we create a CAD design using Autodesk Inventor. To start off, we create a project first. A project is a place to store our designed parts and designed assembly. We can name it as our own project. And we can choose where to store the project. After creating a project, we can create parts. Select create new part and we choose a metric standard for this design. Next, to start off CAD design, we start with 2D sketch and choose the work plane we want to work with. Start off by creating a rectangle and adding some constraint. For this one is vertical and horizontal constraint. And then adding the dimensions. Creating dimensions and constraint is to make sure that our design does not move at all. In this section, we try to create 3D printed parts for 3D printer. After we have created a 2D design, we select extrude to create our 3D models. To create another feature, we start to building our sketch on new plane. For instance, we choose a bottom plane in this one. We start to create a hole using a circular sketch and adding some dimensions and reference to the first 3D printed, the first 3D models we create before. We create another circle that has same and we create another circle that has the same center with the previous circle. Then adding some dimensions. And we create dimensions to determine the length of those two circles. Okay. We can erase our previous sketch using a trim tool in the modify tab. And to connect two circles with lines, we can use the tangent constraint. we create another line and trim the unused sketch and finish it off. After we create the sketch, we can select the closed sketch to extrude to a 3D model. In this case, we join the previous model with the newer model we create before. And here's how it looks. It's still rough, and we can create another 2D sketch on the same plane. We can also use the previous geometry designed by clicking the project geometry. We're extruding another feature. In this case, we extrude to the selected body or face rather than using exact measurements. Of course, after we create the extrusion, we can also modify the sketch to modify the extrusion. So we don't have to delete the steps and repeat it, but we can edit it in a midway. We start off with a new sketch. And if the previous sketch are bothering you, we can select the visibility into a non-visible sketch. We start off building a small holes to create a thread hole for bolt. And adding some dimensions. To place the hole perfectly. And we have a small holes that has a location fitted to create a thread hole for the lead screw. And we can multiply the number of holes by clicking the circular pattern, by choosing the geometry and the axis of rotation and the number of holes. And we're done. We create 4 holes by utilizing the circular pattern, and then we extrude them and we choose to cut because we want to make a hole. And then we cut according to the depth of the hole, and we start. In this case, we create a placement for the nut that constrain the lead screw for the 3D printed parts. We can just create a circle that match the previous circle to make rooms for the nuts. It's easier than to create hexagon like actual nuts, and it's easier to print later. Choose same dimensions and then we extrude. And we're done. We are basically done with the actual design, and we added some holes in these sections. We create 2 parts. That is, the first one we call it an axe idler, and the second one is the pulley holder. Both of these parts will be 3D printed and used in 3D printing machine. We start off with creating a rectangle and adding some constraint and dimensions. We could also add fillet right now, but I don't think it's necessary because we can also add the fillet later. To generate a structural integrity in the parts, and we extrude. We cut off the hole. We create a hole within the extruded part. We also create 2 circles for the linear staff or the linear beam. Adding some dimensions. And we're done. We're basically done with the rough part. So we can add fillet to create a smoother part and a structural integrity of the design. So we don't have a residual stress on the corner points of the design. Almost forgot, we have to create a hole for the bolt that will hold the pulley holder to the X idler. Adding some dimensions and constraint to make sure that it does not move, and then creating the extrusion. In this case, we cut it until the next body. Okay, and we're done. We added some cutouts for the bearing holder, so that the linear bearing would be able to press fit into the design. Apparently we cannot add that constraint to that point. In this case, we just make sure that our sketch is sufficient, and we're done. Create the extrusion through all of the parts, and here we are. It is the X idler part for that will be 3D printed for a 3D printing machine application, and we're adding more fillet to smooth out the edges of the part and avoid the residual stress to the part, to the construction part. And done. We have created the 3D design, a CAD design of the X-idler for 3D printing application. See you on the next design.